So,
Welcome to the deep dive. Our mission today, well, it's pretty focused. We're giving you basically the ultimate shortcut for setting up a fully functional local development environment for PostgreSQL.
yeah, we want you to get past all those common frustrations, the installation clashes, complex setups, forgetting passwords.
Exactly. We're aiming straight for a zero-friction, repeatable setup that just works.
And the key to cutting down that friction is really about strategically using Docker Compose. We've looked at the notes on combining PostgreSQL and Adminer, that popular web UI, to create something fast, self-contained.
And crucially, passwordless and persistent.
Those are the two big ones, yeah. Passwordless and persistent.
Persistence is so important, right?
Yeah.
I mean, a dev environment that just vanishes when you restart your machine, that's not really a workspace. It's more like a sandbox.
Right, you need reliability. So today we're going to unpack the config for the two main services from the source material.pgdb, that's our PostgreSQL database, and Adminer, the web interface you'll access locally on port 8080.
That's the plan.
Okay, let's get into this blueprint then. The sources really emphasize that every choice in this configuration is deliberate. It's designed specifically to fix those common headaches developers face.
Absolutely. It's not just your standard off-the-shelf Docker setup. Let's start with the database service, pgdb. The config points to the image docker.io postgres.17-alpine. Alpine, that jumps out straight away, lightweight.
Exactly. Using the Alpine variant means it's smaller, pulls down faster, uses fewer resources. It feeds right back into that mission of being quick and low friction to get started.
Okay, makes sense. Then there's the port mapping. Inside the container, Postgres listens on its usual port, 5432. But this setup maps the external host port 6432 to it. Why 6432?
Ah, that's a really important practical detail. It's basically a defensive move.
Defensive against what?
Against yourself, potentially. Many developers, maybe you listening right now, might already have PostgreSQL installed directly on your computer.
And it's probably using the default port, 5432. Almost certainly. So if this Docker Compose file also tried to grab port 5432, Docker would just, well, fail. You'd get a port conflict error right away.
Right, and instant friction. Not what we want.
Exactly. So mapping 6432 on the host to 5432 in the container neatly avoids that collision. Your containerized dev database can run happily side by side with any native Postgres you might have.
That's smart. It anticipates a common problem. Okay, let's talk persistence again. How does this setup guarantee my data doesn't just evaporate when I stop the container?
That's where Docker volumes come in. The configuration defines a named volume called ped data.
Big data, okay.
And it maps this pig data volume to the specific path inside the container where PostgreSQL actually stores its data files, which is varlib PostgreSQL data.
So Docker manages this pig data thing.
Right. And it makes sure that all the database files written to that path inside the container actually get stored in this managed volume area on your host machine. It lives outside the container's lifecycle.
Meaning I can stop, remove, even rebuild the container.
100 times. And your data, your tables, everything you've put in there remains safe and sound in that pig data volume, ready for the next time the container starts up.
Okay, that covers persistence. And the source material also mentions something about robustness, a health check, to make sure Adminer doesn't try connecting too soon.
Yeah, that's another crucial piece for making this smooth. The health check configuration uses a standard PostgreSQL command, pgdb.
pgdb, okay.
It basically pings the database inside the container to check if it's fully up and accepting connections. The config specifies how often to check, like every 10 seconds, how long to wait for a response, maybe 5 seconds, and how many successful checks are needed in a row, say 5 retries.
So it's not just checking if the process is running, but if it's actually ready for work.
Precisely. This little section prevents a really common annoyance in multi-container setups, race conditions, where Adminer starts up super fast and tries to talk to the database, but the database is still, I don't know, initializing its tables or something, and you just get connection errors. Right. The health check ensures Adminer waits until pgdb gives the definitive I'm ready signal. Smoother startup. Got it. Okay, database is up, persistent and robust. Now, the really interesting part, the identity, this passwordless goal. How on earth does that work without, well, a password? This is where it gets clever. Using the environment you're already in, your shell environment. Instead of hard-coding a password in the docker-compose.yml file, which is, bad practice anyway.
Right, easy to forget or accidentally commit to Git, exactly. This setup dynamically uses a shell variable that already exists.
Okay, so
That's just my standard operating system username, right? Like, if I log into my Mac or Linux box as Deviser, then user is Deviser. That's the one. And here's the trick. In the PGDB service definition, 3 crucial environment variables are all set to USer. Which 3?
PostgreSDB, which sets the default database name, PostgreSuser, which sets the default superuser name, and crucially, PostgreSpassword, which sets that user's password.
Wait, so if my username is divisor, the database is named divisor, the user is divisor, and the password is divisor.
Exactly. When the PostgreSQL container starts, it reads these environment variables and configures itself accordingly. The default database and its owner are intrinsically linked to the local system identity of whoever ran the docker-compose command.
Huh. So you don't need to remember a separate database password for local development because it's just your username?
Correct. It completely removes that mental burden. Your local identity becomes the credential for your local development database.
Yeah.
Surprisingly simple, but really effective at reducing friction. Okay, so the database is set up with this user-based identity. Now, how do we get Adminer to automatically use it? Let's shift focus to that Adminer service, the UI running on localhost 8080. Right. So Adminer needs to know a few things. First, it needs to know that the PGDB service actually exists and is ready. That's handled by the dependsyn pgdb instruction in its service definition.
Okay, so it waits for PGDB based on that health check we discussed.
Exactly. And second, it needs to know how to connect. Since both services are running in the same Docker network created by Compose, Adminer can simply use the service name, pgdb, as the host name for the database server.
Ah, okay. Internal Docker networking handles that resolution.
Yep. And third, it needs the credentials. Just like the database service, Adminer is configured using its own set of environment variables.
And I bet those variables also use USERR. You got it. The Adminer environment variables tell it. The server is PGDB, the database system type driver is PGSQL, and the username, password, and default database to connect to are all, once again, USERR.
So the connection details are pre-filled, effectively.
No.
They are. If you stopped right here, you could navigate to localhost on 8080, and you'd see the Adminer login screen. But the server, username, password, and database fields would already be filled in with your USERR value. But you'd still have to click the login button.
Correct. And that's still a tiny bit of friction, isn't it?
Yeah.
It is. And that's where this custom autologen thing comes in. The bit using the adminer index.php file injection.
Okay.
This sounds like where the real hack happens.
It's definitely the most, let's say, bespoke part of this configuration. It leverages a Docker-Compose feature called configs.
Okay, configs, what does that do?
Think of it as a way to manage configuration files that aren't secrets, like passwords or API keys. Those would use secrets. Configs lets you define a config file, maybe locally or right in the compose file, and then tell Docker to mount that file into a specific location inside the running container.
So you're overriding or providing a specific config file at runtime.
Exactly. In this specific setup, the docker-compose.yml defines a config that contains a slightly modified version of Adminer's main entry point file, index.php. And it tells Docker to place this custom adminer-index.php file inside the container, right where Adminer expects to find its standard index file. So when my browser hits localhost.80860, it's actually running this custom script first, before the normal Adminer stuff. Precisely. It acts like a little preprocessor. And the magic is just a few lines of PHP code added to the top of that file. It starts with a simple check.if.count, TET.
Okay, TETT. That's PHP stuff for URL parameters, right? The things after the question mark. You got it. So .count.get basically asks, does the URL that triggered the script have 0 parameters in the query string? And when would that happen? When you first navigate directly to http://localhost.8080 in your browser, that initial request is clean, no parameters. If you are already logged in and clicking around inside Adminer, the URLs often do have parameters like .server pgdb and db or db or something.
Okay. So this if statement detects that very first fresh visit to the login page. Exactly. It identifies this user just arrived, probably expecting the login form.
And if it detects that fresh visit, what does the custom script do?
This is the clever part. Instead of letting Adminer show the login form, it programmatically fakes the form submission. It reaches into Adminer's own environment variables, the ones we said earlier, using USEs for the server, username, password, driver, PGSQL, and database name. Yeah. It grabs all those values,
okay,
and then it manually stuffs them into another PHP variable called popus-toth. Popus-t is the array PHP uses to hold data submitted from a form.
So it's like the script is saying, hey, Adminer, don't worry about showing the form. I've already received the login details right here in the POVST data, just like if the user had filled out the form and clicked submit.
That's a perfect way to put it. It preemptively populates the expected submission data structure using the credentials derived from USER. Then, the rest of the standard Adminer code loads, It checks POCET, finds the submitted credentials, validates them, which works because they match the database config, and boom, you're logged in.
Without ever seeing login screen or clicking a button. Exactly. It's a subtle but powerful modification that delivers that final piece. The truly automatic, passwordless experience when you first hit the URL. That is a beautifully engineered bit of configuration. Okay, so you've got this docker-compose.yml file complete with the service definitions, the volume, the health check, the USR adject, and this configs block with the PHP injection. How do you actually launch it all? It's pleasingly simple, just the standard docker compose command, the docker compose up. However, the sources specifically recommend adding the force recreate flag. So docker compose up force recreate. Why the force recreate? It's particularly useful, maybe even necessary when you're changing the compose file itself, especially adding or modifying things like the volumes or critically here the config section. It tells Docker, don't just reuse the existing containers if they're running, definitely tear them down and build new ones based exactly on this current YAML file. It ensures your latest changes, like injecting that custom PHP file, are definitely applied. Good tip. Ensures a clean slate reflecting the current config. So you run that command, wait for the logs to show the database is healthy.
And then you just open your web browser. Navigate to http://localhost.8080. And thanks to that custom index file doing its magic, you should bypass the login screen entirely and land directly inside Adminer connected to your personal US Air database running in PostgreSQL.
Persistent, passwordless, ready to go, mission accomplished.
Fast, persistent, and zero friction. That's the goal.
There is, however, one little catch mentioned in the source material, a limitation to be aware of.
Ah, yes, an important one. While this specific setup, particularly the autologen part relying on the configs block, is confirmed to work well with recent versions of Docker Compose.
It doesn't play nice with Podman Compose.
That's what the notes explicitly state, yeah. Podman Compose, the equivalent tool for the Podman container engine, apparently doesn't handle this specific configs feature in quite the same way.
So that clever PHP file injection, the core of the autologen, likely fails.
It seems so. The underlying mechanism for how Docker injects those config files into the container's file system at runtime might differ subtly or significantly from how Podman Compose attempts to do it. The result noted is that the autologen just doesn't work.
So you might get the database running with Podman, but you'd lose that seamless UI access. You'd probably land back at the Adminer login screen, maybe pre-filled but requiring the click.
That seems the likely outcome based on the source's caveat. It highlights a potential portability issue when relying on very specific features of one container orchestration tool.
Okay, good to know. So let's just recap the main achievement here. We've seen how Docker Compose can be used not just to run containers, but to build a really optimized, functional, persistent development environment.
Yes, specifically for PostgreSQL and Adminer in this case. We minimize the setup pain by cleverly integrating your local system identity using USER for all the credentials.
And then implemented that, well, nifty programmatic autologen using the configs feature to inject a custom script.
And what this really means for you, the developer listening, is that tools like Docker Compose are incredibly powerful for slashing the time you waste just setting things up.
Instead of messing with local installs, dependencies, environment variables.
You run one command, open a URL, and you're immediately ready to work on your application, writing code, designing tables, testing queries. It shifts your focus instantly to where it should be.
That time saving is huge over the course of a project. Now, building on that Podman incompatibility point, it does raise a fascinating final question for you to think about.
Okay.
This setup clearly depends heavily on Docker's specific implementation of the configs block for that autologen hack. When you're designing development environments or even production systems, and you know that different teams or platforms might use Docker versus Podman or other tools, how do you approach ensuring portability?
That's a great question.
If you rely on a feature like this, which works beautifully in Docker but breaks in Podman, what's the trade-off? Should you avoid such platform-specific optimizations for the sake of broader compatibility, even if it means sacrificing a bit of that zero-friction experience? Or do you document it clearly and say, this setup requires Docker, and maybe digging deeper? What are the underlying technical differences in how Docker Compose and Podman Compose handle configuration injection via something like the configs block? Understanding that difference might reveal alternative approaches that are portable. It's something definitely worth exploring if cross-tool compatibility is important for your context.